Alrighty, and we are back with another video, guys. This is episode 3 of Phoenix DB development, and I'm sharing with you guys some of my latest progress. So I've revamped the entire command handler. I've also added a time to live feature for all the database keys. I've also added some encode test instead of using a Python script because it's just easier to do at first. And then also just some general refactoring. So let's go ahead and run through that real quick. So I guess I'll start with the command handler, which is in commands and then mod.rs. And you can see right here that we have three main commands right now: insert, lookup, and delete, which should be self-explanatory. So I have this command parameters, which is passed to all the commands. So all the commands, um, when I say commands, I'm talking about like a database commands, like a delete, insert, update, because all of it's using JSON. So this entire struct to net command is what is sent from this is what the client sends to the server, right? So we have the name of the command, the keys it can contain, which is an optional vector, because not every command needs a key, um, or well, really most commands actually need a key, but it's optional. And then values, not every command needs a value or a time to live, right? And these are vectors because I wanted to have support for like bulk updating. So say you wanted to insert like, um, 10 different values. Instead of having to make 10 different API requests, you can literally send all the data inside of an array, right? And each index should match up with the required values. And I don't really have any checks to like check the count. Like, okay, let's check if the keys are 10 and the size of the values is 10. And if they're not, just fail the entire transaction. I should probably do something like that because most times you don't want to, you know, make null keys, right? But for now it's like whatever. But yeah, and then the response is pretty much the same. So yeah, each command basically in the actual command handler, so we'll look at one in a sec. This is the args it takes. It takes a single command argument, which is a key and a value, right? And DB value has been updated as well to have a value, which is a JSON value, which from sort a JSON, and it expires in, right? And this is a duration. Now the reason it's a duration is because Serde cannot desterilize instance, right? And I'm curious if there's like a method on duration, like if you can convert a duration to a number, because that might be easier to save than this. Because I was messing around with Python, and durations don't get formatted the same. It's weird. It's some typing things, but like Serde is pretty strict. Like if you send some data over the wire from another language, and Serde can't deserialize it, then it's just gonna like not run the command. So I have to figure that out. But yeah, what was I saying? Yeah, so we have this command args, and then we have this trait right here, command executor, right? And this is implemented for f, which is a function pointer, which is um, attached to all of our commands. If I go over there right here, if I go right here, you can see we have a command executor attached to these commands. And this basically just gives in my opinion, cleaner but also more modular way of running commands and attaching this execute function to them, right? Which just calls its internal function pointer, right? And I had to do a few things like, add this, dynamic, the box, the send, all that, just to make things thread safe. And this arc, because the more complex I made it, the more errors I ran into, and I just had to make, Rust tries to make sure everything's memory efficient and safe, right? Which was pretty fun. So the types look kind of crazy now, but it makes sense. It's not too bad, and I think it's a good system for it expanding, which is really important because it's easy to write shit code that works, but to write decent code that you can, mo writing good modular code is a challenge. So yeah, I like to think this is decent at least though. But yeah, then we have this execute command, which is called by um, I tried to like so like how many lines is this? This code is a little over like 250 lines, right? This code used to be like 370 something or 300 or something, but I wanted to like break out most of these pieces because before it was kind of like in an if statement, a big if statement, where now it's in a match statement, and just depending on the command, it handles that certain operation, which all these do is build this little execute command statement, which really runs the real command, right? Because this execute command calls uh, the execute function on the function pointers for the commands, which calls them. And now this code gets ran. And that sounds kind of like inheritance and a little bit crazy, but it makes everything really modular when you think about it. And it's just really great because I could have wrote all of this in like one function. I could have kept all of this inside of the TCP stream, right? But that's not very good for debugging and, having a bigger code base. So yeah, this code just runs this. Obviously, it just returns the result or returns an error if there's an error. Um, you know, this executes the command. So the cool thing is that for the inserts, right, these are going to be single argument commands. So we just take a key, then a db value, which is the value, right? But for bulk, right, we do many, right? And this many allows us to just pass in an array, right? An array. So um, it just depends on the type of command being ran. That way we can have type safety, but also keep the code really flexible. So that's why we use an enum right there. Um, and then yeah, I mean mainly the code is pretty much the same. I guess in here because we have this command args now, we can sort of parse the arguments depending on what type of command is ran. So if command.single is matched, then we know that this is simply a key and a value being inserted into the database, and it's not an array. So we can do what we need to with that. And let's see, I don't actually think do I need that still? Oh yeah, I don't even need that really. Um, what was I gonna say? Yeah, one cool thing though I did. So right here inside of the insert, so the insert, so the database is pretty much a hash map, and as long as your network isn't trash, um, there should be as little latency as possible, right? Like it's just a TCP server. There's no crazy magic code. There's no caching, nothing. It's just read and write, and it's all from memory, right? So performance, because I had someone on my last video comment like, are there any benchmarks on my database and stuff? No, but it's using Serde, which is one of the most popular Rust libraries for parsing. I mean, not for parsing, for sterilization and desterialization, which is already super fast, and it's an in-memory hash map, so it should be light years faster than um, most needs, even though I didn't optimize anything, right? Like, is there even a point of caching a thing like something like this when like it's already in the cache? Like, I don't know. I don't really feel like I need to optimize this. I think I just need to make features and make sure there's no bugs, I guess, right? The one idea I did have though was to have like file persistence maybe with this. Where like maybe periodically, or maybe it can be a command in itself where like it just dumps all the database data into a file. And I'm not sure about that, but it was an idea. Um, but yeah, one cool thing though, I kind of got lost sidetracked, sorry. One cool thing is that in this many command, so when you want to insert like records at the same time, we make a temporary hash map, right? And the reason we do this is because hash maps in Rust, they have a feature where you can extend the map, right? And most languages have this, but you can extend it, right? And what this does is basically it takes your old map and your new one, and it just merges them together. And this is one operation, right? Versus looping over this array of many inserts and inserting, because what we want to avoid is locking the database as much as possible. So locks are, it's only locked, I believe, on writes and deletes. Um, but reads are not locked. Like many different clients can read the same data at the same time. So because of that, we can do the looping and inserting it before we ever have to lock the database, and we can just extend the hash map. So I think that's really good. I mean, like I said, everything's so quick, always seems fast, regardless of what the code I write. But I'm assuming that's a good thing to do, right? And then I also have some tests, right? I have some tests that I wrote pretty much in every single command. Everything works. All tests are passing. You can see up here, all tests are passing. We're good to go. I don't want to write any Python code. The reason I switched my test to Rust, Python was good in the beginning, but I think I have a good enough like structure, and I kind of have a good modular API that I wanted where writing the test isn't bad. It's really bad to write complex tests and then refactor everything and now all your tests break too and you got to do all that. So I wanted to wait a little bit. Um, and also it's just kind of a pain to like test in two different languages because like I said, I want to write the client libraries or any other kind of code outside of Rust once I have a stable working API. So that way I can debug and but I still know the server works. You know what I mean? Versus like update the server, then I have to, oh wait, I forgot to update my test in another language, and I was running into bugs when I was trying that were like I was sending a value that was a float and not an integer, and Surday was looking at it weird, and my test file was like 300 lines also, which isn't a lot, but it's like I don't want to deal with that right now. So you know, like the Rust compiler telling me my stuff is broken first before Python. Um, Plus, all the errors were being caught by my network code, so it didn't even have the full like stack tracing or anything. It was just a error message. So that was fun. But yeah, so I guess the time to live functionality is literally just a Tokyo interval. It's being passed in here, and we basically have a loop, and then we tick, and this tick waits based on the interval passed right here. And then we basically just loop over every single key in the database. So assuming you don't have like 50 million things in memory, it should be quick. But even if you did, I mean, pretty sure a computer can read 50 million keys in under a few seconds. Um, yeah. So it basically just checks the now of this loop and sees if the keys expire. And I plan to have this set. I would prefer. It's kind of sucks because like I could have it like every 30 seconds, like check, but something about this doesn't feel good to me because I'm like, okay, what if you had like a million keys in the database? Every 30 seconds, the entire database would be locked, and the more data you store, the longer. It's like an N of O or whatever that, data structure is, but it's like an exponential growth problem where the more you grow, the longer the cleanup task is going to be. So for now, this is just kind of what I've decided to do. You know, temporary solution. I haven't actually written any tests for this code because I tried to once and it just froze. My computer was like running the test for like 3 minutes and I was like, okay, I don't know. And there's like no errors, so I was confused. But yeah, that's pretty much it. Those are the updates on the library so far. It's going pretty good. What are my next steps? My next steps at this point are to write more commands, write more tests, make sure everything's good. I also have some classwork to do though, and some calculus to get to, so I will be getting back to that. But yeah, database, little fun little side project. Um, yeah, I'll catch you guys in the next video. Drop any comments you have and start the repo if you wish. Later.